Hello everyone, and welcome to the Phosphors and Quantum Dots Industry Forum. My name is Jason Hartlove, and I'm pleased to be able to bring you this talk today about quantum dots and how they are reinventing the display industry. Today we'll step through a few topics on quantum dots in the display industry. First of all, how have quantum dots changed the display industry? And we hope to give you some examples that you can take home and really think about. And second, how will quantum dots continue to reinvent the display industry in the near future? And for this, we'll talk about both what's going on in academic research as well as in the industry and what we're going to be seeing in the next few years coming to market. But first, let me tell you a little bit about my company, Nanosys, and the solutions we bring that create exceptional visual experiences. Our solutions are based on the two most efficient, scalable, and perfect emitter technologies available today, quantum dots and micro-LEDs. Quantum dots, a technology we pioneered and are the world leader in, are the perfect emitters with near 100% internal quantum efficiency. These narrow band emitters are perfect for RGB displays, giving them the ability to render colors that the eye can see, but which are beyond even what is found in nature. Objects exist in nature, but our stories and our data do not, and only quantum dots can create the beyond lifelike visual bridges to the world the digital domain can offer. For creating the next generation heads-up display and augmented reality display paradigms, our micro-LED technology is perfect, enabling picture-generating units up to 100 times brighter and 30 times higher resolution than what can be achieved with OLED. This tremendous brightness and resolution allows us to project visual data into the field of view and have it visible even in bright daylight when seen on car windshields, in our glasses, at storefronts, and the myriad places that visual display of information will enhance our daily lives and commerce in the near future. So let me turn now to how have quantum dots changed the display industry. For that, let's take a first-hand look at what we see out in the real world when we think of quantum dots.
Good morning, everyone, and welcome to the Quantum Dot and Phosphors Industry Forum. My name is Jason Hartlove, President and CEO of Nanosys, the leading technology in quantum dot and micro-LEDs. Today, I'm very pleased to welcome you to the conference, and you've already heard at this point from Eric Verret and Bob O'Brien about some exciting things that are going on in the display industry, adoptions of new technology like we've never seen before in the industry, record profitability, and overall a transformative era that is about to begin in display as we begin to see our data become part of the environment around us with augmented reality, heads-up displays, and other new form factors soon to take the stage. At Nanosys, we've been commercializing quantum dots since 2013, our first products coming to market with Amazon back in that time frame. Since then, we now have over 600 models of consumer SKUs in the marketplace. So we thought, given everything that you've heard, maybe we'd like to add a little color to the presentation today and head down to our local favorite retailer and show you just some of the products that you might be able to find if you go into the retail environment today and look for quantum dots. Come on with me. And here we are right off the bat. The first thing we see is this Samsung QLED 75-inch TV and its environmentally friendly packaging, in keeping with the sustainability that we see quantum dot products providing to the market. This year, Samsung announced that its Neo QLED series was up to 11.6% more energy efficient than any other TV in its class, due to the use of quantum dots, which create the perfect high-efficiency, low-loss RGB spectrum for the perfect TV viewing experience. Let's see what else we have here for sale. Off the escalator, Insignia has joined the quantum dot party with QLED products priced as low as $500. These displays give the consumer access to the premium TV segment at well below $1,000, unheard of. Next up, models from Hisense, including the U6G, which this year Arting's called the best budget QLED TV you can buy. Hisense is bringing more than 25 SKUs to market this year, including this gorgeous 75-inch ULED 4K model featuring full array local dimming. And over here we can see the beautiful TCL 6 Series Mini LED, about which CNET noted no TV we've ever tested offers this much picture quality for this little cash. TCL will ship over 50 models to market this year worldwide at a range of consumer accessible price points. Let's see what else we can see. Vizio can always be found here in retail, and this year they're bringing more than 14 models to the US market, including their M and P series. Features such as quantum color, Dolby Vision, and more provide amazing picture quality at value price points to the consumer. As Wired Magazine noted in April, the gorgeous quantum dot display makes Vizio's M series the best TV you'll find for $500 or less. $500! Quantum dot truly has come to the mainstream for consumer. All of these products we're seeing are really bringing quantum dot with its incredible picture quality and energy efficiency to the mainstream consumer market. Looking at this wall of quantum dot TVs, it is truly inspiring to see how far the industry has come since the first products were introduced in 2013 in the Amazon Kindle Fire and TVs from Sony. This year, we're also seeing new ultra-premium brands enter the market with quantum dot, such as OLED powerhouse LG, who have introduced their QNED mini LED displays with color and brightness exceeding what can be found in OLEDs and non-QD TVs. This is another great validation of the performance and quality that QDs can bring to OEMs, as they offer both value and performance to their customers. And it looks like we have a face-to-face shootout here, as the Samsung QLED appears to be staring down the QNED across the aisle. I'm not sure this is really planned, but if we move down a little further into this store, we can see the quantum dot flagship brand in Samsung and their Neo QLED display pavilion. This year, Samsung will have more than 70 QLED products in the market, ranging from a 13-inch notebook to a 49-inch gaming monitor to a gigantic 98-inch TV, where there is something for everyone. Whether it's mini LED, high efficiency and brightness Neo QLEDs, or innovative concepts such as the frame, quantum dots have helped Samsung maintain its position as the world's #1 TV brand since their first quantum dot product intro in 2015. Personally, I'm so excited to see all of this for our industry. If we count up all of these models, not just the dozens we've seen here on display at our local retailer, but at all the retail shops and online forums around the world, we can see more than 225 new models being introduced this year alone. Quantum dot products have now been featured by more than 35 consumer brands since 2013 and are viewed every day by millions of consumers around the world. Thanks to the continuous innovation and leading-edge research we see coming from both industry and academia, new breakthroughs such as air stability, high flux tolerance, and thin film deposition have been pioneered and are being introduced to market, bringing access to this amazing technology to more and more consumers every year.
I hope you all enjoyed that little field trip. As you can see, quantum dots have been proliferating in their use with all of the top brands in the CE space. And from this slide, which shows the vintage of brand first introductions and total SKUs by year and cumulative volume, the technology is well deployed in the Tier 2 and Tier 3 brands as well, which has enabled quantum dots to become a global phenomena. Whether you go into a Best Buy, Walmart, or Costco in the US, surf to Alibaba in China, or visit an eMart in Korea, you will find local and global brands featuring quantum dots in gaming, automotive, entertainment, and professional displays. With over 600 SKUs in the market to date, and accelerating growth in both brands, models, and units, quantum dot displays are used by tens of millions of people around the world every day. QDEF, or quantum dot enhancement film technology, was the first implementation of quantum dots to reach scale. Introduced in 2013, this technology brought the wider color gamut and the lifelike color spectrum, along with higher energy efficiency, the ability to use the technology to get better viewing angle, deeper contrast, more local dimming, due to the perfect diffusion that QDEF was able to provide. It's a drop-in solution that allowed the industry to rapidly move to quantum dots as a primary technology for premium television. And quantum dots are now going mainstream, bringing all of those great consumer benefits such as high color gamut, high dynamic range, and high brightness to market. In addition, quantum dots are increasing profitability for TV OEMs. If we look at same model size TVs using quantum dots and those without, we see an average difference in the retail segment of a selling price of $140, but an implementation cost of only $16 on average in 2020. This is providing up to a 9x return for the OEM on the incremental investment in quantum dot technology. With these benefits for the consumer, which are clear and visual in the marketplace, as well as improvements in profitability, it's no wonder that quantum dot is going mainstream and enabling this exceptional picture quality and increasing ROI. I'd like to turn now to talk a little bit about how quantum dots will continue to reinvent the display industry in the near future. One way we can do that is by looking at innovation metrics, such as patents. And from this analysis from Derwent, we can see that the top 10 patent holders now have over 13,000 patents worldwide in effect. Although the number of patents overall last year dropped precipitously to only 820 granted from the 1623 the year before, we believe that this is likely impacted from patent office closures around the world due to COVID-19. But in general, we see a strong long-term trend here as the top 10 patent holders continue to increase their position in this key technology for future of display. Another way in which we can gain insights into just what might be happening in the future with quantum dots is to understand what researchers are working on in terms of quantum dot behavior and understanding it. As a key topic for academia, this past year has seen a lot of progress in understanding OJ non-radiative relaxation and the higher flux stability that is necessary for quantum dots to be able to be used in new applications, such as direct illumination and micro LEDs. These are two of my favorite papers from this past year. The dynamic lattice distortions driven by surface trapping in semiconductor nanocrystals, published in Nature Communication, and the survey, the Semiconductor Quantum Dots, Technological Progress and Future Challenges, published in Science. I encourage you all to look at these, as well as many other key publications that are out there in industry today. This progress in higher flux stability is coming very rapidly, and this will unlock many ways for quantum dots to be used where they are not able to be used today. In industry, we are also seeing great progress in advancing quantum dot technology, in particular with regard to environmental stability. This has always been a weak point for quantum dots, which have required inert conditions both for synthesis and for use in applications such as thin film deposition and printing. The first generation of materials, for example, required hermetic sealing, such as we can see here from the first generation product we developed at Nanosys in 2007 for a military application. This used hermetically sealed sapphire windows to keep the quantum dots free of exposure to moisture and oxygen. We made great progress in improving material stability and were able to introduce QDEF, or quantum dot enhancement film, in 2013, which used an oxide-coated plastic barrier film in lieu of a hermetic sapphire to protect the quantum dots. And this was less expensive, but still required a complex process to make. However, a real breakthrough came out this year as a result of the past decade of difficult engineering in which we created aerobically stable materials. This has resulted in the latest implementation, such as the extruded QD light guide plate shown here. This component is a key to implementing mini LED backlight architectures, a very hot trend we see in the market today, as the contrast enhancement is profound, resulting in perfect black levels no one thought possible except from OLEDs. This XQDEF component requires no barrier film and is really bringing down the cost of implementing quantum dots to levels compatible with mainstream and even high-volume display costs, as the quantum dots can be directly integrated into the light guide plate and other optical components. And soon, quantum dots will deliver even more differentiated visual experiences. The first of these will be QD OLED, which will bring photonically pumped red, green, and blue emitters pumped by blue OLEDs to create hyper-realistic color for the first time on large panel OLED. This will enable all of the great things you've come to expect from OLEDs, such as perfect contrast ratio, and all of the things you expect from quantum dots, such as the perfect colors, all together in one visual experience. Next, we will see QD micro LEDs, where today's micro LED technology is limited in terms of the efficiency that can be had, especially for red color at the very fine pitch. QD micro LED provides a perfect color conversion solution using native GaN high efficiency blue optical pump to create perfect red and green emitter technology. And ultimately, our nano LED technology, a completely solution printed display, enables all of the wonderful benefits of QD OLED, perfect contrast ratio, pixel level RGB patterned emitters with no form factor limits, because this technology is not confined to using mother glass sheets or large flat panels. This will create new visual paradigms, which we've only seen in movies so far. The next generation QD solution moves from improving the performance of the transmissive architecture of LCDs to making the next generation of emissive displays possible. We call this color conversion, and it moves the quantum dots from the backlight to being the optically pumped emitter that is directly seen by the viewer without the inefficiencies of the LCD architecture or the difficulties of patterning RGB OLED in large panels. This is only possible through tireless work in being able to create quantum dots that can be patterned in thin films with high absorption coefficients. As a result, the viewing angle, perceived color purity, efficiency, and brightness are all improved. This technology is a must for large area RGB emitting OLED and for small pixel micro OLED displays, as we shall see in the next slides. We will see this technology first come to market in QD OLED displays in late 2021, and we expect the first QD micro LED displays as early as 2023, with public prototypes having already been shown. Micro LED is an enabling technology for augmented reality, heads-up display, and potentially many other applications where high brightness and ultra-fine resolution are required. However, to make micro LEDs successful, you need small micro LEDs. If you're making an augmented reality display, you may only have 0.1 inch diagonal, and if you want 1,000 pixels across the field, this is 10,000 ppi, which means you need pixels smaller than 2 microns. If you're making a TV, you also need tiny micro LEDs, because if you use large ones, the cost of the LEDs alone will be huge, as you may have 24 million of them in a 4K set and 96 million in an 8K set. And in particular, to be successful in micro LED, you need tiny red LEDs, but it's impossible to make direct emission tiny red micro LEDs with high efficiency and good uniformity and good color maintenance over drive current. Due to the edge effects and long minority carrier lifetime, when red native LED size goes down, efficiency drops tremendously. On the other hand, blue micro LEDs of the same size still have very high efficiency, and red quantum dot color converted micro LEDs therefore can still have great efficiency and maintain color uniformity across the array. This is important not just for enabling AR and any applications where tiny micro-LEDs are needed, it turns out it is necessary for all micro-LED applications. Here we can see a real-life implementation using photo pattern color conversion quantum dots in a 1-inch micro display from Ilidia. This architecture allows a single transfer of blue micro-LEDs onto the substrate backplane and then color coding the pixels using solution-printed quantum dots as the photopumped emitter. And last, but certainly not least, Nano-LED, also known as electroluminescent quantum dot display, has been making rapid progress this past year. We saw product-level demonstrations of completely solution-printed displays using quantum dots, without any vacuum tools or processing, enabling freedom from rigid display substrates and high-temperature, high-cost processing. The 55-inch 4K TV prototype shown by BOE at SID and the all-heavy metal-free mobile phone display, which will be discussed here at this conference from Sharp and Nanosys, demonstrate the readiness of Nano-LED for mass production. This is being enabled by tremendous advances in chemistry, such as the controlled alloying of cubic, low OJ rate, stable QDs with wavelengths tunable throughout the blue color range and with high QY. When used in devices, these materials are providing greater than 10% EQE across a range of brightness and can easily be pumped to 10,000 nits or more. All of this is demonstrated with solution-printed materials, either inkjet deposited or photoresist patterned, delivering fine pitch and high uniformity. This technology, when fully matured, will completely disrupt the ways we think about display by enabling form factor-free implementations, such as on curved and arbitrarily shaped surfaces. All of this is enabled with environmentally friendly, readily available materials, which will continue to transform the display industry. All of these advances in technology mean that quantum dots will rapidly capture an outsized share of the fastest growing segments of the display market. Whether that is in new markets, such as vehicle digitization, where bright heads-up displays are required, or augmented reality and virtual reality, where tiny color-converted micro-LED pixels are going to be the dominant technology. Quantum dots, either optically pumped or as direct emitters, are expected to reach over 1 billion units in total market adoption by the year 2029. This will transcend just the TV market where we see it today, as with solution-printed versions of quantum dots now coming to the market in thin films, we expect to see quantum dots penetrating the mobile phone market and many other segments that heretofore have not been reached by this great technology. As I hope you can see by now, quantum dots lead the advanced TV market today. However, quantum dots are going mainstream within the existing display market, thanks in part to great advances that have been made in creating more stable solutions, which are bringing down the implementation costs. However, the future of display is emissive, whether that is in QD OLED, QD micro LED, or nano LED. Quantum dots will replace transmissive and lossy LCD and white OLED architectures in the near future, in everything from direct view display to advanced new indirect view display technologies such as heads-up and augmented reality. Quantum dots are on every mainstream roadmap for the industry, and the top innovators are continuing to grow their positions, and academia is pouring more and more research funding into this key area every year. And this technology is proven, is at scale, having shipped over 50 million units to consumers worldwide, and with the supply chain and customer traction to deliver it for displays of the future. I hope by now you are as excited as I am about quantum dots and how they are helping to continue to transform the display industry. I want to welcome you again to the Phosphors and Quantum Dots Industry Forum, and I hope that you enjoy the remaining talks throughout the day, which touch on a wide range of topics. I also want to thank our sponsors, Smithers, and I also want to thank and acknowledge the advisory board of the Phosphors and Quantum Dots Industry Forum for inviting me here today. I hope you enjoyed my talk, and if you have any comments, please leave them for me. I greatly appreciate your time. Thank you.